Hello everyone. I am Jayesh and today I am here to discuss about one of the interesting topic that is dynamic link libraries. Let's understand the power of dynamic link libraries and how it is used in various applications. So let's discuss about dynamic linking. So I will explain you with some analogy about dynamic linking and static linking, how they both are different. Let's take an example that you have a very close friend. You can assume you're some any of your best friend and you want to communicate with him in several times a day. You share something with him, he will share something with you, some data, some information. So one approach is to take your friend always with you. He will be always with you at your home whenever you are eating, whenever you are going outside, he will be with you. And whenever you feel talking with him, you are communicating with him. So the complete resource is coming with you all the time. This is the approach in static linking, in which the complete resources, complete functions, all variables, all classes of a particular libraries are put into one exe. All the time they are present in the exe. On the other hand, I can use some different approach that whenever I feel talking with my friend, I will just take my phone and call him from his number and I will be able to communicate with him. This is the second approach. So here I am only having the reference of my friend as his contact number, but I am not having complete my friend with me. So this is a second approach that is used in dynamic linking, in which you are having a reference to all the functions, classes, and variables that you will be using in the application. But that will be at the runtime. When I think I want to talk with my friend, only at that time I am calling him. He is not there with me all the time. So this is the approach that is followed in dynamic linking. So you can see that if I am taking my friend with me, we have a lot of resources, I along with my friend. So resource size is huge. But if I am having a reference of my friend, so I am not having actual resource, but I am having only the reference to it. So size decreases. So this is same is followed in the various applications, big applications. So whenever we are using a dynamic link libraries, so let's assume that we are having any application as a calculator as an application. So in calculator, we might be using various functions like addition, subtraction, division. So in that case, what happens that we will create a library of all those functions and we will use that library with our application, which will be a calculator as an application. So here in dynamic linking, only the references of the functions will be added during the link time. Means in our exe, only the references to the functions will be present, but the complete functions won't be present in the exe. That means the size of the exe reduces, and hence the uh, execution is faster in terms of dynamic link libraries. Let's understand it. DLL are like the shared library on Unix systems. On Unix systems, they are known to be the shared libraries. They are used to share the code and resources across different applications, and they remain in reducing application size by avoiding code duplication. Means let's say if we are having a single DLL, one DLL we can use in calculator application. We can also use this in somewhat complex calculator as an another application. So in that also we will require the basic functions of calculator. So we can use a single DLL in multiple applications. We can use it in a calculator application. We can use it in somewhat different application that also uses this calculation in mobile as an application. In that also calculator is present. So a single DLL can be used in multiple applications. Hence, this here we are avoiding the code duplication and we are performing the uh, reusability of our code. We are not duplicating code and writing different libraries and attaching it. So that is one benefit, which is that we are not duplicating the code, but we are performing a reusability. And the second is that if we are having a single DLL, then a single DLL loads into RAM, and using this single DLL, multiple applications can utilize the functions and classes and whatever resources are there present in this DLL. So only once this DLL needs to be present in RAM. If a single DLL has been present in RAM, multiple applications running on our system can use this DLL. Instead, in case of static linking, every application will have a copy of library with it. If we are having a single somewhat application like of calculator, let's say, so it will be having a complete static library packed up with it, then let's say if we are having a second application, then if we are using the same, if you want to use the same library in the second application as well, then the complete library will be present in that application, so size of both the applications will increase. So we can't use a single library in both. That is a disadvantage of static linking, and there we can rely on dynamic linking. So like static libraries, a DLL can export functions, variables, and resources by name. Like if we are having functions named as addition, subtraction, multiplication, and division. These four functions will be using in the coming project. We will create a project on DLL. So we can use these functions by their names. We can export them by their names, by name of the variables, and resources by their name itself. And we will be having a client application. In our case, we will also be creating one project, so in that, calculator will be our client application, and it will be importing these names of addition, subtraction, addition, subtraction, multiplication, and division by their name itself. So let's understand it. Let's use some code and let's understand it. We can start Visual Studio. So let's create one application in which we are also creating a DLL, and we are also creating a project client application that will be using our DLL. Let's create a new project. Click on dynamic link library as our project type. We will use a math library that we will be importing in our client application. This is our math library. This will be a DLL. This is a library which will be dynamically linked to our exe. It's creating the project. Okay. So this is our DLL project. So in this we can see that we are having a DLL main.cpp. As in any C++ application, in any C++ project, main is a starting function. It is the entry point of the application main function. Similarly, in DLL main is the entry function in DLL. We will discuss more about this, but for now, we will create one header file and a C++ file that will have some code in it that we will be using in our application. You can just right click on project and click on add. You can click on new item, and you can click on .h file. Here we will create one .h file. We will name it as a math library. Okay. So this will be our math library.h, and also we will need to create one .c++ file which will contain the implementation for this header file. Let's create one C++ file. We will name it as same math library. Okay. So this is a .h file, and I will write some code and I will explain it line by line. Okay. So here it should be export, and that should be import. Okay. Cool. So now here what I have done is the first line is hash pragma once. So this is used to make sure that our header file is included only once in our C++ file. Whenever we are including any header file, at that time we might include it twice. We might include it twice. Then this line will ensure that it is included only once. If it's included already, then it won't add it again in our application. Mm. Okay, let's write some. Now we will have some applications as like if we are having a calculator as an application, we will be having several functions in it. Those can be addition, subtraction, division, and multiplication. Let's add some functions in it. This is one of the function. Subtraction I can add int a, int b. Let's give it complete name. It sounds better. Fraction and multiplication and division. So we have defined these functions. Now, will we be actually able to use this in our client application? Because we haven't exported them. We have just written the declaration of the function. Implementation is not present. And even we haven't exported it. How will it know that we are going to export it? So for that, to enable the dynamic linking, Windows need extra metadata that C++ doesn't normally provide. That means in order to export and import, C++ doesn't has any kind of export and import symbols predefined that can be used to export and import these functions. So that is why MSVC means Microsoft Visual C++ compiler. This adds Microsoft specific extensions to C++ to support this DLL. So the Microsoft Visual Studio C++ compiler that we are using here, it will use some of the internal APIs that will be used to export and import these functions. What are these APIs? These APIs are this is a export API underscore underscore tickle spec DLL export is an export API and this one is the import API. So we will use this APIs to say that we are importing and exporting functions in our DLL. So in order to here we are exporting it. So whatever the situation is, according to that, this variable will be assigned a value. Let's say here I am having a math library CPP. So this will contain the implementation of this header files. So here I will define math library exports. That means here I have defined this. Means when I will include my dot header file here. So when I'm including my dot header file here, so it knows that when this file will be imported here, so it will check if hash if this is defined or not. Math library exports this macro is defined or not. So here we have defined this macro. So the value of math library API will become uh, underscore underscore decals spec DLL export. That means in this case, in this file, this will be replaced by this thing. That means the function will be getting exported. But we will have to use this with functions to export functions. So we will use it here. So we have used this with functions, our functions. That means when this file is inputted in .cpp file, this macro is defined. So value of this will be defined and math library API will be assigned to export API. And here also this math library API will be converted to export API. That means functions are exported from this C++ file. Now we will write some implementations for this. Now we will write int add int a comma int b. Okay, so we are having some complete name as addition, int b, and we will simply do a plus b, and int we will do subtraction, int a comma int b, and we will turn a minus b, int multiplication, int a comma int b, D multiplied by B. These are the simple functions, mathematical functions that can be used in a calculator based application. Return A divided by B. Simple functions. Okay. So now here we are exporting our functions, but here we are normally exporting our functions. Means the export type here is not defined. It's just getting exported, right? But what we generally follow, we can say this is a C++ export. But what we generally follow is that we follow a C style export. Why in DLLs? While exporting functions, we will follow C style export. I will explain you why we follow that. Let's first export it in a C style. This is extern C, and we can put a braces here. Then this all will be applied as a C style exports. All functions are having C style exports. We will come to the point that why are we using C-style exports after this implementation. Just for now, we will use C-style exports. So our DLL is ready. Let's build our DLL, build solution. And we can see that a build is started. Project math library configuration is debug x64. So our build is started. Okay. So build is failed. We are saying that one failed. Why it is failed? Let's say warning macro redefinition. Math library underscore exports macro redefinition. Okay. Where have we redefined it? Define exports we have defined. This looks good. Um, this is not. Ah, okay. So we haven't declared here. We will need to include the pcsh.h file. This is must, I guess. It is saying na unexpected end of file while looking for. Did you forget to add this in your source? We will have to add this as well. Let's build the solution now. Okay, so now we can see that build is succeeded and we have built our DLL, means our library is built. Now we are able to use this in our application. Let's see if it is built or not. We can go to this, we can go to debug, and here we can see our math library.dll is present. Somewhat more files, four files are present. We only needed DLL, but what are these three files? We will also come back to this thing. Let's create the application first. Let's create one new project. Let's start Visual Studio again, and we will create one project that will be our client application. That will be a calculator application that we will be using. That will be using our DLL. Let's start it. Mm, Okay, create new project. We will create a console application in C++ that will be using our DLL. So you can just search for console here, and it will search here also. I can see the console app, but I will show you from here. Just see for C++ Windows console, this one. Just create one project with this, and we will name it as a calculator. That's our application. Let's create it. So Visual Studio is creating our project, creating project for us. Okay. So this is a DLL. It will open. Okay. Yeah. This is a project that we have created. Now we will try to use the functions that we have defined in our DLL. Let's say we will use one variable as A, we will use another variable as B, which is 200. We have to add it, subtract it, and divide it. We will do add addition of a comma b. So if we will run this program, do you think will it pass? Because it's giving some red squizzle line that identifier addition is undefined. It is unable to find addition. Why it is unable to find addition? Because this is a compile time error. This is not a runtime error. This is a compile time error. It is saying that addition is undefined. Where have you defined addition? We haven't defined any addition function here. If I am defining addition function here, then it will not throw an error. But we have defined it in our some different .h file, .header file, that is a math library .h. So we'll have to give the reference of that file in this project. So as we have provided our implementation we have provided our declaration of the function in our math library.h, we will try to include it here, math library.h. Okay. So we are saying him that the information about addition you can get in math library.h. There we have defined it. Okay. So, but it's saying that it's an unexpected identifier. It is saying that where can I find math library.h? I don't know that where to find it. So we will have to provide the path to our .h file in properties, in project properties. So just go to the project and right click on it and go to properties, and we will see where our .h file is present. So .h file is present here. This is the math library.h that we are using that has the information about the addition function. It stores it reference. So let's go to our application. So nothing, just I have clicked right click on our calculator and I have went to project. Here we will go to C++ in general. Here we can see the additional include directories, and here we will add our directories here. So here we will add our path to the .header file here in this. So we will do it okay, and okay. So we have added our math library.h in this file, and we can now. So yes, we are back, and this is our client application. Here we are having math library. We are trying to include it, and if you'll go to properties, we are unable to include it because it is unable to find the path to our math library.h file. So here in general, we have to include this path, and that we have already done. Math library. Okay, this is the math library.h, that is that we have included, right? Let's check again the name of the library. It's totally fine. Oh, okay. We'll have to include it. We don't have to define it. We will have to include it. So when we will include this, we will have to add the path in properties and in C++ general. Here in C++, here in general, in additional include directory, we have to add the path of .h file. Okay, so we have added here, and now we can use the addition function here. As if we will try to build my project, build solution, and here I will see it's a build started. So let's see if I can use the functions from the DLL in it or not. I have already written code to use that. So yeah, build got failed. What is the issue? Failure. See, I was having calculator.cpp file. So calculator.obj file is created, but there is a error. What is the error? Error is a LNK2019 unresolved external symbol. Implementation of addition referenced in function main means the implementation of addition function. This addition function implementation is unresolved. Means from where it has came, it is not. It is unable to decode it. That from where have you used addition function? So this is a linker error. This is a linker error because here we can see LNK1120, right? So why this happens? Because at the time of compilation, it needs library.h file, math library.h file. It needs .h file in order to make sure that you are using this function that is defined in a header file. Okay, so at the compile time, it used our header file, math library.h. It says, okay, you have added the information about your addition in that, so it is fine. It got compiled. But at the time of linking, it will ask, okay, you have defined you have declared your function in your .h file, so I also need the its reference where it is present, reference of it. You have just given me the name, but what is the reference, right? So reference of this function is actually present in the .lib file that was generated when our library DLL was generated. Like this is our project of DLL, and in this we had our DLL generated here. So along with the DLL, we also have a math library.lib file. So this is the lib file that was generated, and this contains the references of the functions that we want to export, right? So all the addition, subtraction, division, multiplication references of all those four functions are present in this .lib file. So it will require this lib file during linking phase. So this is the linker error because it was unable to resolve the lib file. It was saying where it is. So we will have to add the reference of .lib file. So here we will go to right click on this project. We will go to properties. We will go to it's a linker error. So we will go to linker and we will go to input. Here we will give name of our library, that is math library.lib. This is the lib file that you have to see if you want the references for our function. Then we will go to general, but we will also have to specify the path to it, where it is, like where it is defined. It doesn't know, na? So let's go to debug. So here we are having our .lib file. We can just give this path here, and this should work. In additional directories, give this path. Okay. Okay. So that's great. Now, if you will try to build it, let's see if it gets built or not. If it's able to find, okay, so it got built. You can see build one succeeded, zero failed. It got built. But are we really able to execute our application? Let's see. Our application, this is a DLL application, and we are having this calculator as an application. Here, are we really able to execute this .exe file? Let's try. See, we are not able to run it. Why? Let's see the error. The code execution cannot proceed because math library.dll was not found. Okay. So it is saying reinstalling the program may fix this problem, but it won't. I will show you the solution. So what is the issue now? We told it during the compilation that use mathlibrary.h file. We have given you the path. Take mathlibrary.h reference from there, and you will get the addition function listed in it. Okay, so it told okay. Then at the linking time, it made a requirement for .lib file that also we provided with path. So it said, okay, I will just create the exe. I will link your .obj files and I will create the exe. But then at the runtime when we were trying to execute our exe, at that time it told that you have given the references, but where is the actual implementation? Now I need the actual implementation. Like when it will call the function addition, where will the implementation reside? It will be in .dll file. That is that is our binary code that contains the implementation of all these functions in the binary format in the machine code. So in order to use that DLL, the one thing is that we can copy the DLL here along with calculator.exe. We can keep here math library.dll. That is one thing, and we can perform that thing with some standard process that is known as the post build event. Like right click on this calculator, go to properties, go to build events, go to post build event, and here we will use one command. I will show you that command. You can use it directly. So this is the command you have to use to perform the post build event. Here just put that command, and in place of the part to DLL, you have to give the part to your actual DLL. So just go to our project. Here we will go to our DLL project. This is the math library. This was our DLL project. Go to x64 debug, and so here you can see this is a DLL. So copy the path of this DLL. Copy as path. Go to a project. Paste it here. Okay. So now what it will do, it will copy our DLL when we will build our project. Let's